you that as the pressure increases, solubility increases, right? So when you open the bottle of any soft drink, the carbon dioxide that is dissolved, it comes out with a high pressure. That is excess carbon dioxide that comes out with a high pressure. So why is that soft drink bottles are tightly bottled? I mean, it's very tightly because you have to open it when you open it, the carbon dioxide comes out with a pressure, right? So these soft drink bottles are bottled under high pressure, right? Why? Because these soft drinks have carbon dioxide or a gas which is dissolved in solution, right? And we know that the gases are soluble in liquid under high pressure. That is why these bottles are closed under high pressure, right? There is a high pressure that is applied on these bottles, right? And when you open the bottle, you have released the pressure, right? Pressure is decreased, so the carbon dioxide that is dissolved in liquid comes out. That is the solubility of the gas in the solution decreases when you open the bottle. That is, when you decreases the pressure, the solubility of gas, carbon dioxide, decreases in solution. That is why it comes out, right? There is another application, that the people that are living on high altitudes, we know that at high altitudes the pressure is less, right? So and we know that for proper functioning of the body, the blood should contain sufficient quantity of oxygen, right? Because it's through blood that oxygen circulates in our body, right? Because oxygen combines with hemoglobin to form oxyhemoglobin, right? That circulates in the body. Now at higher altitudes, the pressure is less, right? So the oxygen that is dissolved in blood, the people who are living in higher altitudes, for them the oxygen dissolved in their blood is less because of low pressure at high altitudes, right? So due to less oxygen in their blood, they may face various kind of diseases, right? They may face like memory issues, right? Or many kind of diseases because of less oxygen in their blood, right? Then there is one more application. If you remember the Bosch process for industrial preparation of hydrogen, the carbon dioxide, the mixture of carbon dioxide, in one of the steps, the mixture of carbon dioxide and hydrogen is passed under pressure through water, right? To separate carbon dioxide from the mixture of carbon dioxide and hydrogen, right? So when you pass the gas mixture of hydrogen and carbon dioxide under pressure in water, the carbon dioxide gas will dissolve in water, because more is the pressure, so more is the solubility of CO2 in water. So hydrogen and carbon dioxide, this way gets separated. And you might have deep sea divers who are called scuba divers, right? When they go inside the sea, we know that under the sea or river, the pressure is high. When the pressure is high, the oxygen that gets dissolved in our body, the oxygen and nitrogen that gets dissolved in our body becomes high, right? So more gas, oxygen and nitrogen gets dissolved in our body, right, under the sea, because pressure is high. So when the scuba divers come up, right, when they suddenly come out of the river or the sea, you see the bubbles that comes out. That bubbles are due to the nitrogen, the excess nitrogen that is inside the body. When it comes out, it is very painful. The feeling for the diver is very painful when the dissolved nitrogen comes out with a pressure, right, out of the blood vessels, and it's very painful, and in some extreme cases it can cause death, right? So, and one more thing, the higher altitude thing that we call, the diseases that the people who are living at high altitude face, we call it as anoxia. I forget to mention that. So in deep sea diving, that is why the scuba divers carry oxygen cylinders. They carry that cylinder because that cylinder contains the air which is diluted with nitrogen. It's diluted with helium gas, right? so it contains less nitrogen because it is diluted with helium gas. Because with dissolved nitrogen we have understood that there is an effect on our blood vessels, because with a very high pressure it comes out of the body, right, which is very painful. So to minimize this effect, the scuba diver carries a cylinder which contains gas, helium, right? Air is diluted with helium, right? So all this is comes under Henry's law, application, limitation, right? And this derivation, this quantitative relationship is very important, right? All this mole fraction, right, of the gas and the partial pressure of the gas, right? Just try to understand this. And this graph, since solubility is directly proportional to pressure, right, so we get a straight line, right? All this is very important, and I hope all this is clear to you. Thanks.